You're welcome to this video. This is Dr. Arda again. I want to treat this course called linear programming. Now, linear programming is a tool that is used in industrial engineering, business administration, mathematics, and other fields as well. You always come across a system, where you have limited resources around you. And what you want to do is to harness all those resources and see that you come out with the best output. So in linear programming, we're always talking about optimality. Linear programming is used in the field of manufacturing and production, in the field of transportation and logistics. It's applied in healthcare, in the energy industry, in business and management, in agriculture, and in other fields. So let's jump into the example we have for the day. Let's look at this problem. It says a manufacturing company produces two products A and B using two machines, machine 1, machine 2. The company wants to maximize profit. We should calculate the quantities of products A and B to be produced to maximize profit. Let's say given data, product A, profit is equal to $40 per unit. Product B, profit is $30 per unit. That means when a unit of product A is produced, when we manufacture a unit of product A, we're going to make a profit of what? Of $40. If we manufacture a unit of product B, we'll have a profit of $30. They're coming here. We also have a requirement here. It's a machine time requirements in hours per unit. Product A uses 2 hours on machine 1, and 1 hour on machine 2. Product B uses 1 hour on machine 1 and 2 hours on machine 2. The machine availability, the machine 1 can work for 100 hours per week, while machine 2 can work for 80 hours per week. And at the same time, we have this condition: both products must be produced in non-negative quantities. This is what you call the non-negativity constraint. Let's formulate a model and solve this problem. Before we formulate the model, which is the first step, let's draw a table. Thus, we have a table here to at least have a clearer picture of what the problem is. Here we have product A, we have product B, total machine hours. Now say, let X1 be the number of units of product A to be produced. Let X2 be the number of units of product B to be produced. Now, if we look at it, product A can spend 2 hours on machine 1. Product B can spend 1 hour on machine 1. Meanwhile, machine 1 has 100 hours per week maximum. If we divide this by 5 working days a week, that will be 20 hours a day. The meaning is that this machine 1 can work for a maximum of 20 hours a day. If you work for more than 20 hours a day, you are overstretching the machine. So the maximum it can work is 100 hours a week, 20 hours a day. So in this case, it means for this condition to be met, if we produce X1 units of product A, you have 2 times this 2X1, that's on machine 1, this machine 1, we have 2, 2X1, on that machine 1, we're talking about total machine 1 hours here, and we have 1 hour on machine 1 for X2 plus 1 hour product B. If you add all of them together, the total must not exceed 100. That's the meaning. Same thing for machine 2. Machine 2, 80 hours per week. So we have 80, and for machine 2, we have product A, 1 hour on machine 2. So that 1X1, Then product B, 2 hours on machine 2. That is 2X2 must not exceed 80 hours. That is the tabular form of this problem, Whatever the quantity of X1 and X2 we're going to produce, it should satisfy this table. So from here, I think we can formulate our linear programming model. The next thing we're going to do is to get the objective function. If you see here, this condition conditions 1 and 2, okay, they're for the constraint, but these are objective function. The question says, calculate the quantities of products A and B to be produced to maximize profit. We are maximizing the objective function, so you write, say maximize, okay, Z is equal to, we said product 1 is X1, you have X1, okay, plus X2, okay. Then we said the profit for producing each unit of product A is $40. So we write it here, that's 40, okay. Then for product B is $30. You can see that. Write it 30. Yes. So this is the objective function. So maximize Z equal to 40x1 plus 30x2. We'll now go back and formulate the linear programming problem. And so to write out the standard linear programming problem, we'll say maximize, okay, Z is equal to 40x1 plus 30x2, okay, then subject to, okay, we have here 2x1, okay, this is the first constraint, okay, 2x1 plus x2 is less than or equal to 100, okay. Then for the second constraint we have x1 plus 2x2, okay, is less than or equal to 80, okay. Then after that we have the non-negativity constraint. We have the non-negativity constraint, that is x1, x2 greater than or equal to 0. This is the simplest method for solving this equation. Okay, there's the first step to formulate the linear programming problem. There's it. Maximize Z is equal to that, subject to, there's the first constraint, there's the second constraint, and there's the non-negativity constraint. The next step is to now write it out in a standard form. After writing down the linear programming problem in standard form, just as we have here, step 2 is to write the problem in standard form. And to do that, we add slack variable, okay, S, to both the constraints and the objective function. We have start with the objective function. We have maximize, okay, just write this right hand side, 40 x1, okay, plus 30 x2, subject to, okay, the first constraint, you have 2x1 plus x2, okay, then you add a slack variable according to the number of equations, this equation 1, so we call it S1, slack variable 1, okay, then plus we're going to add another one here, okay, plus this, we're going to add another one here later, so let's give a space here, equal to, what's the condition there, what you have, we are converting the inequality sign, the less than equality sign, to what? To equality sign. Therefore, we add a slack variable. For the first equation, for the first constraint, slack variable S1. So you have 100, write 100 there. Okay. For the second one, we have x1 plus 2x2 plus, we'll leave here, it's going to be 0 here, then plus s2, slack variable 2, is equal to 80. Okay. Then here, this s2, so here will be 0, okay, 0 s2, and here will be 0 s1. When you come to the objective function, we now have plus 0 s1 plus 0 s2. Yes. Now, then after that, we have that x1, comma, x2, s1, s2, they are all greater than or equal to 0. Okay. This is the simplest method, okay, written in standard form. is it in standard form. What we mean is that these are slab variables. They're actually resources that you may exhaust at the end of the solution, or you still leave some. You may exhaust them, or you may not exhaust them, depending on what the constraints require. Okay, that's what the slab variable means. The slab variable is an unused resource, okay, that you'll be using in the course of optimizing or iterating or maximizing the problem. So this is the standard form of this linear programming problem. Now, after representing this LP problem in the standard form like this, step 3, you draw the initial tableau for the simplex method. Okay, so you come here, you draw this table here. Look at it. You have 1, 2, 3, 4, 5, 6. 6 rows by 1, 2, 3, 4, 5, 6, 7, 8. Okay, so you draw a table of 6 by 8. Okay, 6 rows by 8 columns. Then here, this point here, this is what you call the basis. That's the basis. Okay, the bases are going to be here. So what you do is to fill in the tableau, okay, using this standard form. This is the CJ row. It's called the CJ row, which is here, CJ. Okay, put the values here. So under CJ here, you have, under X1, you have 40. Okay, under X2, you have 30. Okay, S1 is 0. S2 is 0. That is the value of the slab variable S1 and slab variable S2 in the objective function is 0. Okay, now this is the basis. Then the basis, you have these slab variables being in the basis in the initial tableau. So you have your S1, okay, you have S1, you have S2 here, okay. Then coming down, this is the CJ row, CJ row. The S1, what's the value of S1, okay, in the CJ row is 0. The coefficient is 0. Put it there. For S2, the coefficient is 0 as well. Put it there. Okay. Then X1, this X1, this is the first constraint. What's the coefficient of S1 in the first constraint here is 2. Put it there. Okay. Then coming here, in the second constraint, coefficient is 1. Put it there. Okay. X2, okay. What's the coefficient in the first constraint? 1. You come there, that's this. Then here, 2. Then S1. What's the coefficient of S1? Okay. In the first constraint, this first line, this first row here, the first row here, this is the first constraint, this is the second constraint, okay. And that's called the A matrix. That's this point here. 2, like this. This is the A matrix. So let's continue. So S1, in the first constraint, what's the coefficient? Is 1. Put it there, 1. Okay. In the second constraint, what's the coefficient? 0. Okay. Come here, S2. First constraint, what's the coefficient? 0. Okay. Then here, S2 is 1. Then on the right hand side here, first constraint was here, 100. Write it there. Okay. Here is 80. That's it. Okay. So after that, this is the ZJ row. The ZJ row is gotten by multiplying these two values, this column by the unit, by the columns here. So you have 0 times 2, give us 0, plus 0 times 1, 0. So here will be 0. Here will be 0 times 1 plus 0 times 2, that's 0. Here will be, the value here will be 0 times 1 plus 0 times 0, that's 0. Here, 0 times 0 plus 0 times 0, that's 0. Here is 0 times 100 plus 0 times 80, that's 0 as well. Value of ZJ here, okay, the objective function here, the value is 0, okay, at the initial tableau. Then to get the CJ minus ZJ row, subtract the ZJ row from the CJ row. So we have 40 minus 0, will give us 40 here. Okay. 30 minus 0 will give us 30. Okay. 0 minus 0 will be 0. 0 minus 0 will be 0. Okay. That's it. There's nothing here. You leave this place. Okay. You don't write anything here. This is CJ minus ZJ row. Don't write anything here. Okay. Now, this is the initial tableau. At this stage, S1, the slab variable 1, has a value of 100, okay, and S2 has a value of 80. That means this resource, the value of this resource is 100, the value of this resource is 80. Okay, we're going to be taking from these resources, the two resources, okay, to maximize our objective function. And at this point as well, the value of Cj minus Zj is 40 for x1, and it is what? 30 for x2. Okay? And at this point, look at it. S1, where S1 and S1 meet, you have 1 there. So this is actually a unit matrix. This is a unit matrix. The tableau will give us the initial solution, which is not optimal, with x1 and x2 not in the basis. Okay? You can see x1, x2, they are not in the basis. All variables that are not in the basis have a value of 0. The slab variables S1 and S2 will be in the basis for the initial solution. At this stage, x1 is equal to x2 equal to 0, and s1 is equal to 100 here, okay, and s2 is equal to 80, and at the same time, the objective function, which is z, is 0. That is at the initial tableau. Now, if we introduce x1, if x1 is in the basis, it's going to increase the profit by 40. Likewise, x2 being in the basis is going to what? Increase the profit by 30. So this is the increase in the profit when this x1 here enters the basis. Now, in this case, you ask yourself, is this tableau optimal? That's the first question. If it's not optimal, then we are going to iterate. Okay, we carry out the first iteration. How do you know whether the tableau is optimal or not? You look at the Cj minus Zj row. Okay, if all the values are not 0 or negative, it means it is not optimal yet. All the values here must be 0 or negative. Okay, all the values here must be either 0 or negative. If they are greater than 0, then it's not optimal. Then you now ask yourself, which variable should come into the basis? Look at the highest, the one that will have the greatest contribution, okay, to the profit, and this is the x1. So this is going into the basis. Meanwhile, if you have two values that are equal, you can take any of them. X1 is going into the basis, So this is what we call the pivot column. Okay, this is the pivot column. That's the pivot column. A pivot column. After getting the pivot column, next we now ask ourselves, what is going to be the element that will leave? Because on the pivot column we have 2 and we have 1. To determine the pivot row, okay, pivot row, this is the pivot column within the pivot row. To determine the pivot row, we take the ratio of the right hand side, okay, to each element in the pivot column. So at this point, here we have 100, taking the ratio will now be 100 all over 2. So we have 100 over 2, that will give us 50. The next one is 80. The ratio here is 80 all over 1, which is equal to what? 80. Okay? The lesser value is this. If the two values are the same, you can take any of them. These are pivot row, and this is what we call the pivot element. This is the pivot row. Okay. Now the intersection of the pivot row and the pivot column is the pivot element. So our pivot element is this. Therefore, x1 is going to enter the basis while s1 is leaving the basis. Let's draw the next tableau and see how we take it off from here. Now that we know the pivot element, which is these two, and we also know that x1 is coming into the basis, we fill in the next tableau. Okay, you come here, you go to the Cj row, okay, fill it up like that. You have 40, okay, 30, 0, 0, and here x1 is coming to the basis. So you fill in x1 here. Here s2 is still there. S2 is still there. Good. Then you come here, this point here, the coefficient of x1 in the CJ row, what's it? What's the value? In our CJ row is 40. Okay, it's 40. Okay. Then under X here, under X, you have 1 here. 1. That's it, that's 1. Oh, you feel that? Okay. Here, the coefficient of S2 under the CJ row, remember, is 0. Fill it in there. That was it. The next thing is to fill this row. Okay, fill this row up. Now you ask yourself, here we have 2 in row 1. The corresponding position is what? Is 1. So what do you do to 2 to get 1 is to divide by 2. Therefore, you divide all the elements of that row by 2. Therefore, here we have 1 over 2. Here as well, we have 1 over 2. 0 over 2, we have 0. 100 over 2, we have 50. Okay? Then after that, we come here, because we need a unit matrix here under the variable, the decision variable, under the decision variable that's coming to the basis. So here should be 0. Here is 0. Now you ask yourself, what do you do to this point here, to this cell, okay, this cell, to get 0 in relation to this R1 here? This is the pivot row. This is the pivot row, okay? Remember, the pivot row from the previous table, from the old table, we divided by 2 to give us this row. Okay? So this is the pivot row. So what you do is this. You multiply this pivot row, okay, by a constant and subtract it from this old row here. So if I can write it out, if I may write it out for you, it's going to be, we have R1, let's call this row R2, okay, this row R2. So let's call it R2 old. R2 old is this row, while here this is R1 new, okay? This R1 new, while this row is R2 new. Okay, this is R2 old, this is R1 new, and this is R2 new. And so you will find that we want, this place is 1, and here we want it to be 0. So you multiply R1, okay, by a factor and subtract from that. So we now have R2 new, okay, look at this formula. R2 new, okay, is equal to R2 old, okay, then minus, you use a factor to multiply this pivot row. You multiply the pivot row, let's call that factor x, minus x times our pivot row. Okay, that's the formula. If we have to deal with, if it's more than this, we have maybe row 3. So we have R3, okay, R3 new is equal to R3 old minus x times the pivot row. Likewise, R1 new is equal to R1 old minus x times the pivot row. Okay, now in this case it may not be obvious because our value here, the element here is 1. So if we have to substitute this to get the value of 0 here, okay, to get the value of 0 here, you go to the corresponding position in the old table, okay, that would be 1, okay. So for example, this is our R2 new now. Our R2 new here, our R2 new is equal to, talking about this point here, okay, why we should get this place 0, for here to be 0, okay, that will be equal to our R1 old, that's R2 old, and our R2 old is this 1 minus a factor. This x is a factor. Now this x is actually the element here, which is what? 1. So minus 1 into the pivot row. You count this, the pivot row here, okay? The pivot row here times this. This is the pivot row, the element there at that position. This is 1. So we have 1 here. That's equal to 1 minus 1, which is 0. Okay? So that's why here is going to be 0. Let's go for the next one. I want to treat for this value here. Okay? For this point here, we have R2 new, okay, is equal to R2 old. You go to the old position there, okay, which is 2, okay, 2 minus x. X is the factor, is this point here, 1, 1, minus 1 into the pivot row. Where's the pivot row? Is this one, okay, which is 1 over 2, okay, you have 1 over 2. That will be equal to 2 minus half, okay, which is equal to 1.5, which is 3 over 2. So here it's going to be 3 over 2. Okay, the next one, okay, is R2 here is equal to R2 old, which is 0, 0, minus, okay, the factor here, this is the point, this is the factor, which is our x, the value here, factor here, that's 1, okay, into the value here, okay, which is what? Our pivot row, this element here, half. You have 1 over 2. That will be equal to minus 1 over 2, okay? So let's fill here. There will be minus 1 over 2, okay? Let's go to the next one. The value here is equal to what? R2 old, 1, minus the factor here, 1, into, okay, into, that's the x here, times PR, pivot row, which is what is 0. Okay, you have 0 there. 1 minus 0 is equal to what? 1. So here is going to be 1. Let's go to the next one. The next one is going to be R2 old, 80, okay, minus the factor, which is here, this is a factor, 1, into, okay, then multiply the PR, okay, pivot row, which is this, 50. So 80 minus 50 is equal to 30. Can you see that? That's how to fill in this row. And that's what we call elementary row operation. Okay, then after that, you fill the other rows. To get the 0, okay, is what? 40 times 1 plus 0 times 0. So 40 times 1 is 40 plus 0, that's 40. Okay, 40 times half is 20 plus 0 times 3 over 2 will be 0, so that will be 20. Okay, here is 40 times this is what? Is 20 again. 0 times minus half is 0, so here will be 20 as well. Okay, then here 40 times 0 plus 0 times 1, that will be 0. Okay, then here will be 40 times 50, here will be 2000. Then let's go to the CJ minus ZJ row. Okay, that will be what? 40 minus 40, here will be 0. Okay, 30 minus 20 is 10. Okay, then we have 0 minus 20 is minus 20. 0 minus 0 is 0. Okay, here you don't do anything here, you just leave this one like that. Okay, so this is our tableau from the first iteration. The next thing is to check the ZJ minus CJ row whether the tableau is optimal. Is there any value here that is greater than 0? The answer is yes, 10. Okay, 10. So this variable will now enter the basis. This will now be our pivot column. The pivot column, okay, this is our pivot column. Let me draw a rectangle on it. Now this is our pivot column, 10. This is our pivot column. Now after getting the pivot column, this row 1, this row 2, okay, this row 1, this row 2, how do we determine the variable that will leave the basis? Is it x1 or is it s2? Remember, we divide the right hand side, okay, by the corresponding element in the pivot column. So 50 over half, okay, that will be 50 times 2, which will give us 100, okay. Then here 30 over 3 over 2, okay, 30 divided 3 over 2 will be 30 times 2 over 3, okay, that will be, this will cancel, we're left with 20, okay, this is 20. The first one is 100, isn't it? This is 100, this is 20, which is the least value there, is 20. Therefore, this variable here is leaving the basis. Therefore, this is the pivot element, which means S2 is leaving the basis, and X2 is coming into the basis, okay? It's like this. Yes, we have X2 coming into the basis and S2 leaving the basis. Then we'll carry out our next iteration. Now we're here to carry out the second iteration. We have seen that decision variable X2 is entering the basis while S2 is leaving the basis. So you come here, you write it out again, X1 here, X2 is coming into the basis, right? X2, okay, then our CJ row 40, 30, 0, 0, okay, we have 40, 30, 0, 0, okay, then you come here, X1 is here, the value of the coefficient of X1 in our CJ row is what? Is 40, you write it here, okay. Then X2, the value, the coefficient of X2 in the CJ row, you write it here as well. Okay, that's it. Then here, you come to the X2 that's coming to the basis. This is X2, okay. At this point, where they meet, the column and the row meet, that will be what? 1. Good. Then from here, you go back to the corresponding position in the old tableau, okay. In this case, here, this is our R1 old, that's the row, R1 old, okay, while this is R2 old, okay. Coming here, this is our R1 new, okay, and this is our R2 new. Now, if we look at this, what's this position here from the other table? From here, this is this position, this is 1, okay, this 1, it corresponds to this position here. So what do you do to 3 over 2 to get 1? Is by multiplying it by 2 over 3, okay, 2 over 3. Therefore, we'll multiply all that row by 2 over 3 and put the value here, okay. So here, 2 over 3 times 0 will give us 0. Okay, here 2 over 3 times minus 1 over 2, that's the value that will be here. Okay, you look at this entry here, the pivot row here, is the pivot row, this is the pivot element itself, but this whole row is the pivot row. Then you ask yourself, what must have been done to the previous entry here to get 1? This is 3 over 2. If you multiply this by 2 over 3, it will give us 1. Therefore, you multiply the whole row by what? 2 over 3. So, minus half times 2 over 3, minus half times 2 over 3, that will be minus 1 over 3. So, here will be minus 1 over 3. Okay? The next one, this 1 times 2 over 3, that will be 2 over 3. Okay? The next one, 30 times 2 over 3, 30 times 2 over 3, that will be 20. Okay, so that's how to get the value for this row. After that, we now get a 0 value here because it's going to be a unit matrix. We need a unit matrix at the point where you have the variable that is in the basis. We have a unit matrix there. So it should be 1 here and 0 elsewhere. After getting this, you look at this entry here. Here it's going to be 0. Okay, this point is going to be 0. So remember our formula that this for this row 1, because this row 1, that we have R1 new, okay, is equal to R1 old minus, because the sign there at this point here, this corresponding position, this is what? This is positive. If it were to be negative, if it were to be minus half, then our sign here will be plus. Because we want to ask ourselves, what do we use to multiply this pivot row here, okay? Multiply this pivot row so that when you subtract it from the corresponding position here, it gives us 0. So if the sign here, okay, this point here, if the sign here, this where you have half here, if the sign is negative, this will be positive. If it is positive, it will be negative. So in this case, it will be negative. So minus x times our pivot row. Okay, so if we substitute this point here, this is 0. Okay, you see that R1 new is equal to R1 old. What's our R1 old? Is half minus x. X is the value that is there, the element at that position. The element at this position. This is what you use to multiply every other element in that row. Okay, so this is half. Can you see? This is half now. Okay, this is half. Our x here is half. So that will be 1 over 2 into the pivot row. What's our pivot row? This is our pivot row. The element there, which is 1. This one here in this case is 1. So that will be 1. Okay, so that will be giving us half minus half is 0. So that's why here is going to be 0. We do the same to the remaining cells. Okay, now coming to this position, okay, coming to this position, let's say R1 new, okay, is equal to R1 old. Where's our R1 old? Is this is it, R1 old half minus x. What is x? Our x is the value here. Is this half? Half, okay, into the pivot row value, which is this value here, minus 1 over 3, okay, minus 1 over 3. That will be equal to half, okay, plus 1 over 6. LCM is 6. That is 3 plus 1, which is what? Which is 4 over 6, which is 2 over 3. So here is going to be 2 over 3. There will be 2 over 3 over 3, okay? For the next one here, okay, R1 new is equal to, talking about this point now, remember this is the corresponding position, is equal to R1 old, which is 0, minus, okay, the factor, which is x. And what's our x? Our x is what? 1 over 2 into, okay, the pivot row. What's the pivot row value here? Is this 2 over 3. 2 over 3. So that will be equal to 0 minus, this will go, minus 1 over 3. So here will be minus 1 over 3. Minus 1 over 3. Now talking about this place, okay, we have R1 new. R1 new is equal to R1 old. Where's our R1 old? 50 minus, okay, x. And our x is what? Our x is this 1 over 2. Minus 1 over 2 into the pivot row. This is our pivot row element here. The pivot row element, 20. Okay, so that will be equal to 50 minus 10, okay, which is 40. So this point is going to be 40. That's it. Okay, so the next thing from this, we still need the value here. We need the value here, okay, let's come here as well. To get the value here, R1 new is equal to what? R1 old, which is what? 1 minus x. Our x is what? Our x is 1 over 2, which is a factor. 1 over 2 into the pivot row. This is our pivot row element here, which is 0. 0, okay? That will give us 1 minus 0, which is 1. So at this point, it is 1. Can you see how it's working out? That when you have x1, the corresponding value must be x1 too, so that where the two of them meet is going to give you 1. So this, you can see this is a unit matrix 1, 0. For x2 that's in the basis, it's a unit matrix. So you can easily check if you are making errors or not. Okay? x1 here, the junction here, the intersection must be 1. If it must be in the basis. x2 here, the junction here, the intersection must be 1. If it must be in the basis. That's it. So let's continue. After that, let's talk about our zj row. That is 40 times 1 plus 30 times 0. That will give us 40. Here, 40 times 0 plus 30 times 1 will give us 30. Here, we have 40 times 2 over 3 plus 30 times minus 1 over 3. That will be 40 into 2 over 3. Okay. Plus, this becomes minus 30 into minus 1 over 3. 30 into minus 1 over 3. That will give us 80 over 3 minus, this is 10. Okay. That's 10 minus 10. LCM is 3. We have 80 minus 30. Okay? Because this over 1, 3, that's 30. That'll give you, this is going to give us 50 over 3. So this will be 50 over 3. 50 over 3. Okay? Now coming to this one, we have 40 times minus 1 over 3. That is minus 1 over 3. Times 40, okay, plus 30 times 2 over 3, plus 30 into 2 over 3, okay, that will give us minus 40 over 3, okay, plus this will cancel, we have 10, 20 over 1, LCM 3, that will be minus 40 plus 3 times 20, 60, okay, that will give us 20 over 3, okay? So it will be 20 over 3. Now the next one, 40 times 40 is 1600 plus 30 times 20 should give you 600, okay? Add together, that will be 0, 0, 2, carry 1, that's 2200. So here it's going to be 2, 2, 0, 0. Okay. After that, we now calculate the CJ minus ZJ row. Go there. 40 minus 40 is 0. 30 minus 30 is 0. 0 minus 50 over 3 will be minus 50 over 3. Okay. Here, 0 minus 20 over 3 will be minus 20 over 3. Okay. Here, you don't do anything here. Leave this. So if you watch the CJ minus ZJ row, okay, is there any value there that is greater than 0? No. Therefore, this tableau is the optimal solution. Okay. After the second iteration, we have arrived at the optimal solution. And the result here shows that X1, which is product A, is 40 units, while X2, okay, is what? Is 20 units. Well, we're going to produce 40 units of X1, which is product A. We're going to produce 20 units of product B, and at that time, the maximum profit is going to be $2,200. Okay, let's write it out. You can now say solution. Okay, so the above tableau is the optimal solution, okay, for the linear programming problem. Now say product A to be produced is equal to what? 40 units. Okay. Product B, okay, to be produced is equal to what? 20 units. Product B to be produced 20 units. And at the same time, now say maximum profits, okay, profit is equal to what? $2,200. Okay, that is the answer to this problem. I want you to share this video, at the same time subscribe to my channel. Thank you for watching.